Assalamualaikum warahmatullahi wabarakatuh. Kami daripada kumpulan AUBURN akan membentangkan case study number 1. Nama saya Irfan Fauzan Ahmad bin Nur Faizal, and my matrix number is AA 212790.
My name is Muhammad Hasudi bin Faizul. Matrix number is AA 210581.
My name is Muhammad Imran Faiz bin Lokman, and my matrix number AA 210726. So I would like to present about acknowledgement. So first and foremost, we would like to praise and thank Almighty Allah for giving us the strength and that. Thanks to His blessing, we have finally managed to fulfill this assignment. Without His blessing, we would have gone this far. This assignment cannot be complete without effort and cooperation from our group members, which consist of Ahmad Hakimi bin Muhammad Zaki, Irfan Fauzan Ahmad bin Nur Faizal, Ismi Muhammad Imran Qais bin Lokman, and Muhammad Izzuddin bin Faizal. We always work hard for produce a good assignment with our full commitment and responsibility. Therefore, we would like to acknowledge with thank our lecturer Mrs. Nohana binti Muhammad, because without her guide, our assignment cannot be done properly like this. She always gives us support and guide on how to do our assignment in purpose to produce a good outcome. She inspired us greatly to work in this project. We also like to thank her for teaching us in this course. Last but not least, we would like to express our thankfulness to University Tun Hussein On, UTHM Campus Pago, for giving us opportunity to conduct this writing report assignment. Finally, an honorable mention goes to our college in developing the project and people who have willingly help us out with their abilities. That's all from me. Thank you.
Okay, for the program statement or the diagram, our group we get case study number 1. Okay, so for the question is a research group plans to make flower pot out of clay. So the basic idea is that the pot is described by the function 1/4 x square and has height of 6 starting from y equal 3. So before they start making the pot, the calculation need to be made so that the clay is enough and fully used. They start by sketch the graph and finding the area of the pot. Then surface area of the pot also need to be calculated. Okay, for the filler table, F is for fact, I for idea, L for learning issue, and A for action. Okay, for the fact, firstly is a research group plan to make flower pot out of clay. The basic idea is that the pot is described by the function y sama dengan 1/4x kuasa 2 and has a height of 6 starting from y equals to 3. Okay, so for the second fact, before they start making the pot, the calculation need to be made so that the clay is enough and fully used. And for the number 3, they start by sketch the graph and finding the area of the pot. Then the surface area of the pot also need to be calculated. Okay, for the ideas, problem they may face. Firstly, the size of the flower pot may not be appropriate. And secondly, clay may be wasted, and the surface area of the flower pot may not be suitable. Okay, for the learning issue, we must use formula integration to get area. And firstly, we must use formulas surface area and trapezoidal rule, so we can find the surface area of the flower pot. And for the action, the reference we get is from the book and match the questionnaire based on information that found in the internet.
So for the introduction, we have seen how integration can be used to find an area between a curve and the x-axis. With very little change, we can find some areas between curves. Indeed, the area between a curve and the x-axis may be interpreted as the area between the curve and a second curve with equation y equals 0. In the simplest of cases, the idea is quite easy to understand. Another geometric question that arises naturally is, what is the surface area of a volume? For example, what is the surface area of sphere? More advanced techniques are required to approach this question in general, but we can compute the areas of some volumes generated by revolution. As usual, the question is, how might we approximate the surface area? For a surface obtained by rotating a curve around an axis, we can take a polygonal approximation to the curve as in the last section and rotate it around the same axis. So this is the graph. So that you can see the graph is there on the upper line, and that there is 3 coordinates. First is negative 6,9, second 0,9, and third is 6,9. And for the second line, they have also 3 coordinates. First is negative 3.4643, second is 0.3, and third is 3.4643. Okay, for the first solution is the flower pot, area of the flower pot. So first is that we need to use the area formula, which is integration. We need to use integration. So we need to put the coordinate in the formula, and that when we put it in the formula, we can use the integration solution to get the answer. And for the final answer is that we got 58.144 units square. Okay, next is that we need for the second solution is surface area. We need for the surface area, we know that the y volume is 1 per 4 x square, and for the x volume is 6 and negative 6. So with the surface area formula, we put the x and y volume in the area in the formula. And after that, we multiply the square root with 4, and then we can get the equation. After that, we need to use trapezoidal rule. We need to use it for solve the problem and get the solution. So in this trapezoidal rule, we use h equals 0.5, and for a and b is for a volume is negative 6 and b is 6. This all volumes we need to put in the formula of n, so we can get the volume of n, and that we can solve the surface area. Okay, after that we need to build the table of the trapezoidal. In the table we can get the total of the sum. So the final sum is 113.842, and the second is 302.230. So after we get the total sum of the in the table trapezoidal, we put it the volume of sum for the volume of the sum in the trapezoidal rule, in the formula of trapezoidal. So after that we we get the answer is 179.576. We multiply it with 2 pi because we need to find the surface area in the formula. We need to find the surface area of the flower pot, so we multiply it by 2 pi. So the final answer is 359.152 pi.
For the conclusion, we have seen how integration can be used to find an area between a curve and the x-axis. With very little change, we can find some area between curves. The conclusion we get from the report is we can use integration to solve the problem that involves finding area of region, volume by cylindrical shells, and arch length and surface area. There are many applications of integration. For example, to find the center of mass of an area having curved side, to find the area between two curves, to find the area under a curve, and the average value of a curve. So, an integration is a function of which a given function is the derivative. Integration is basically used to find the area of the two-dimensional region and computing volume of three-dimensional object.